All right, hey, sorry guys, had some technical difficulties there, so this video will be split into two sections. So we're still looking at 5.5, theorems about polynomial equations. We're talking about this rational root theorem, that the answers to this thing, the x's that make it true, are always going to look like this p over q, where p are the factors of 5, and q are the factors of 2. All right. So here we'd done this one together, and we were halfway through this one before I ran into a little bit of a glitch there. So we're going to finish this up. So again, I'm trying to find the one of these that works. So we go 3, 7, 6, -8, and let's just work down the line. So I did 1, and then I checked 1 through. Let's try 2 here. All right. And I can go through and check all the negatives. So I add, and then I multiply, and then I add, and then I multiply, and then I add, and then I multiply. Not going to work. All right. Hopefully this one works because I'm running out of room. So 3, 7, 6, -8. Let's try 2/3. Okay. Sometimes fractions work out. A lot of times they don't, but we'll give this one a try. So I add, and then I multiply. 3 times 2/3 is 2. I add. 9 times 2/3 is 6, and then I multiply. Oh, there it is. All right. Phew. Okay. So the only rational root of that thing is 2/3. Okay. Now, the other option, let me just point this out to you. The other option, if you say, man, that's a lot of synthetic division, it's a lot of guessing, checking. It is. The other option is just start plugging these things in for x. All right. For some of you, that might be easier. Put 1 in for x, see if you get 0. Put 1/3 in for x. That's really what we're doing. Again, some people prefer the synthetic division. Some people prefer to put that in for x and see what you get. I'll leave that to you. But if we put 2/3 in there for x, it is the one that gives us 0. Okay. All right. So finding rational roots, that idea of the rational root theorem, p over q. Okay. So the other thing that I want to look at is once you find one root of a polynomial, you can use that to get a quadratic. All right. And then once we've got a quadratic, once we've got something that's an x squared, then we've got other things to find those other roots. All right. Like the quadratic formula or maybe factoring. Okay. So here it says find all the rational roots of this thing. Okay. So again, p are all the factors of 2. All right. So that's 1 and 2, the positive and negative of it. Q is all the factors of 15. So that could be 1, could be 3, could be 5, could be 15. Okay, so all the different factors there of 15. So p over q are all the different fractions I can make of p over q. So I can go 1 over 1. I can go 1 over 3. I can go 1 over 5, or I can go 1 over 15, or I can go 2 over 1, 2 over 3, 2 over 5, or 2 over 15. Okay, I know my answers. I know my answer is in here somewhere. It's in that list. 1, 2, 3, 4, 5, 6, 7, 8, and then times 2 because I got all the positive and negative of those. I mean, I've got 16 different choices there as far as what it could be. All right. So again, you can start plugging these in for the x's, see which one gives you an answer of 0, or you can go synthetic division. Okay. So I'm gonna go synthetic division. 3, 2. They didn't skip any. I don't need to add in any zeros. So here we go. 15, -32, 3, and 2. Let's try the whole numbers first. So I'm going to try 1, see if that works. I'm going to avoid the fractions, save those for last. So 15, I add and then I multiply. I add and then I multiply. I add and then I multiply. Nope, 1 didn't work. All right, let me try 15, -32, 3, and 2. Let me try 2 here. So again, I add, and then I multiply. I add, and then I multiply. I add, and then I multiply. Oh, Good. All right. Phew, I found one of them. All right. Now, it did say find all of them. Find all the rational roots. All right. So there might be more out there. Okay. The ones before it said find the one. They were telling us there was only one rational root. The others must involve square roots or maybe i's, imaginary numbers. But now we can see if this thing has other rational roots. And here's what you need to catch on here. All right. If this started off as x to the third, this is now 15x squared minus 2x minus 1 equals 0. Okay, so now we can solve this either by using the quadratic formula, or I'm going to check and see if it's factorable real quick. Okay, but we don't need to keep doing the synthetic division. All right, so I'm going to see if this thing is factorable. It's got the number in front, so 15 times negative 1, that's negative 15. And are there any factors in negative 15 that add up to negative 2? Yeah, there are. Negative 5 and positive 3. Okay, so I'm going to factor this thing by grouping. 15x squared minus 5x plus 3x minus 1. I group them together, and I can take out a 5x. That's leaving 3x minus 1. And here, really can't take anything out, so I'm just going to factor out a 1. And there's 3x minus 1. And so now I've got 3x minus 1 in common, and I've also got 5x plus 1. And again, it still equals 0. We're looking at where these things equal 0. And so now if I multiply two things together and get 0, either 3x minus 1 equals 0 or 5x plus 1 equals 0. I've got some two-step equations to solve. I add 1. I get 3x equals 1. I divide by 3. There's another root, 1/3. And notice that was in my list. Okay. And here, take away 1 and take away 1. 5x equals negative 1. Divide by 5, I get x equals negative 1/5. And that one was also in my list there. All right, so this one had three possible roots, three possible answers to that. We found one, just kind of with a guess and check. But once I find that one, that gets me down to a quadratic. And from there, I can see if I can factor that thing, or if you're more comfortable doing the quadratic formula, there's your A, there's your B, there's your C. You can plug that into the quadratic formula and find all three roots. Okay. Let's look at another example here. So here's my P. All right, P is factors of negative 6. That could be 1, 2, 3, or 6. Q is factors of 2, so that's 1 and 2, the positive, negative. So all my different combinations of P over Q. Here's my list. I can go 1 over 1 and 1 over 2. I can go 2 over 1 or 2 over 2, but that's just 1. I've already got that listed. I can go 3 over 1 or 3 over 2. And I can go 6 over 1 and 6 over 2, but 6 over 2 is just 3, so I've already got that listed. So my list isn't too bad. 1, 2, 3, 4, 5, 6, and then all the negatives. So I got 12 different possibilities. So synthetic division, 2, 1, negative 7, negative 6. Anybody feeling lucky? I'm just going to go in order with my whole numbers here. I'm going to try 2. I'm going to try 1. Add, multiply, add, multiply, add, multiply, and add. Nope, it's not 1. Let me try the same thing with 2 this time. So this can get kind of tedious if you don't guess right away. So add, multiply, add, multiply, add, multiply. Oh, ding, ding, ding. There it is. All right. So one of my roots is 2. And now, again, the good news is, since it started off as a cubic, the answer down here is a quadratic. It's 2x squared plus 5x plus 3. So if I want to solve that thing, I've got some tools at my disposal to help me do that. Okay, I can do the quadratic formula, or I'm going to check to see if this thing is factorable. 2 times 3 is 6. Factors of 6 that add up to 5. Yep, 3 and 2. So this thing is factorable. So 2x squared plus 3x plus 2x plus 3. So here I group and I group. Here all I can take out is an x, and that leaves me 2x plus 3. Here, I really can't take anything out, so I take out a 1, and that's 2x plus 3. So I got a 2x plus 3 in common, and x plus 1 still equals 0. So I want to know individually when they equal 0. 2x plus 3 equals 0. Subtract 3 and divide by 2. I get negative 3 halves. And when does x plus 1 equal 0? Well, subtract 1. And again, you notice both of those were in my original list. There's negative 3 over 2. There's negative 1. I tested positive 1. Negative 1 also should have worked. But there's my 3 rational roots. Okay? So again, finding P, finding Q, all the different combinations of P over Q. This is what you need to catch. So if you start with a cubic, once you find 1, that gets you down your answer down here after the synthetic division is a quadratic. 2x squared plus 5x plus 3. You've got A, B, and C. You can do the quadratic formula, or like I showed here, you can factor it to find those other two. Okay. All right. One last thing that I want to look at here, and I lied. We are going to look at one other theorem, but this one I think is going to be a lot easier, a lot simpler for you to catch on to. It's what's called the conjugate root theorem. Okay. And basically what it says, and think about how the quadratic formula works. It has that plus or minus in there. It has the plus or minus the square root of b squared minus 4ac. So those answers always come in pairs, one with the plus, the addition of the square root of that, and one with the subtraction. And that's what this conjugate root theorem says. It says, if p of x is a polynomial with rational coefficients, so if it has, coefficients, that we can put on as fractions, all right, decimals that terminate, then the irrational roots, if there are any irrational roots, roots that involve the square root of 5 or something like that, if they come in the form of, excuse me, if they come in the form, okay, of a plus or minus the square root of b, they always occur in conjugate pairs. That means if you know that a plus the square root of b is an irrational root, then a minus the square root of b is also a root. So if you know you've got this one, you know it also has its partner. And again, that all comes back from, from this up here. In a similar way, if all you have are real coefficients, so maybe you've got other coefficients here, maybe you've got some imaginary roots, all right? So basically what that means is if a plus bi is a rational root, then a minus bi is also a rational root. There's also a root of that, okay? So let's look at what that means, all right? It's a lot of mumbo jumbo maybe. Let's put it into action here. So it says that if we have a quartic, all right, a quartic is just an x to the 4th polynomial, okay? And it has rational coefficients, so we're talking here, if the square root of 2, is a root, that means, it says, what are the other two roots? Well, if the square root of 2 is a rational root, that means the opposite of that is also a rational root. And if 1 plus I is one of the roots, then 1 minus I is another one of those roots. Okay, that's all this saying is that if we kind of remember this, all right, that these things come in pairs of a plus and a minus, then once I have this one, I've got its partner. And once I have this one, I've got its partner. I don't need to do any synthetic division or anything else. Okay, similar thing down here. So we've got a cubic, all right? Cubic is an x to the 3rd, so I know there's only 3 solutions. And they've given me 2 of them. What's that third one? Well, if 3 minus 2i is there, then 3 plus 2i also has to be one of those roots. So sometimes we can use this conjugate root theorem to find that twin or to find that partner answer that goes along with these things, okay, without actually having to do synthetic division. Okay. All right, so again, a lot to digest here. This chapter 5 here is a lot to digest. We talked about the rational root theorem, finding all the different possible combinations of P over Q, okay? And then hopefully you're a good guesser, and then finally finding that one that gives you a remainder of 0. Remember, your other option is just take each of these and put them in there for x and see which one gives you an answer of 0 if you don't like synthetic division. Then the other thing we talked about is if you start off with a cubic and you can find one of them that works, that gets you down to a quadratic, which now we have ways of solving that either by factoring or the quadratic formula. And then finally, the conjugate root theorem that says, hey, these roots always come in pairs of a plus the square root of b or a plus bi means its partner is also there, a minus the square root of b and a minus bi. And again, that all comes from this plus or minus sign when you do the quadratic formula. Okay. All right. So I've cut out quite a few of the notes here. So I've cut down the homework quite a bit as well. So the problems that I want you to do are these problems right there on page 316. Give those a try. If you have any questions or any issues, please don't hesitate to contact me and let me know. And hopefully we can work through those together. All right. Take care, guys.